Imagine that I am standing a few meters away from a tree, and on this particular tree in question, there is a bird perching on it, and I want to throw this stone at this bird. In what direction should I throw this stone? Should I throw it horizontally? Of course not, because the bird is at a higher position than I am, so there's no way this stone is going to reach the bird. Okay, should I throw this stone vertically? Of course not, except if I were standing directly under the tree, okay, then I can throw it vertically. But at this particular position where I am standing a few meters away from the tree, for me to correctly strike this target now, I've got to throw this stone at a particular angle to the horizontal. Only then would this stone be able to do what? Strike the bird. You see, this will now take us to a very important topic in physics called what? Called projectile motion. First of all, what is a projectile? In its simplest sense, in the broadest sense, a projectile is any object that is launched into the air and allowed to move by the influence of gravity. This video is going to be focusing attention on the calculation aspect of projectile motion. There are some basic concepts that you need to understand if you are to correctly solve any calculation problem on projectile motion, especially at this O-level stage. But before that, let me now welcome you at this point to this channel. If this is your first time, I am Everest James and a medical student of the University of Nigeria. So if you haven't subscribed to this channel, kindly consider doing so, as you will find it very helpful. But yeah, let's dive into the scene now. Projectile motion. Concept number one. The first concept you need to understand here is that a projectile motion is an example of a two-dimensional motion. In what sense? It is two-dimensional in the sense that as a projectile travels, as in during the motion of a projectile, it covers some distance horizontally and also does what? Covers some distance vertically. You got the illustration of that particular stone I used at the beginning of this video. Okay, for me to have thrown that stone at that bird, that stone must have traveled some distance horizontally because I was not directly under the tree. The tree was in front of me, it was ahead of me. Okay, so for that stone to have struck that bird now, it must have traveled some horizontal distance ahead of me to get to where the tree was. So undoubtedly the stone traveled out horizontally. Okay, another thing there is that the stone traveled vertically. How did I know this? I know this because I know that the position of that bird in question, the bird in question was at a higher height than I was, at a higher position than I was. So for that stone to have struck that bird now, it must also have traveled what? Some distance vertically upwards. Okay, so a projectile motion when inclined at an angle, does what? Travels horizontally and also what? Vertically simultaneously. That is the reason we call it what? A two-dimensional motion. We've been able to establish that any projectile that is inclined at a particular angle to the horizontal will have horizontal motion and also what? Vertical motion. Quite agreed, established, granted. Another concept you need to understand here is that only the vertical component or the vertical motion of this projectile motion is affected by gravitational field. Remember our definition for projectile. We told you, or I told you, that what? A projectile is any object that is launched into the air and allowed to move by the influence of gravity. Okay, it is only the vertical component of that motion. Okay, only the what? The vertical motion of that particular projectile that is influenced by gravity. The horizontal motion of this projectile is not influenced by gravitational force. Why? Because the force of gravity or gravitational force does not act in the horizontal direction. Okay, so the only thing that can affect the horizontal motion is what we call air drag or what is called air resistance. Are you with me? And in most of the questions you'll be solving in your UTME jam, you would be asked to neglect air drag or what? Or air resistance. This concept is very, very important if you are to solve questions on projectiles. If I am told to calculate the distance traveled by a projectile, I will not be using the equations of motion, because those equations of motion, v is equals to u plus at, v square is equals to u square plus 2g8, s is equals to ut plus r8 square, they are equations of uniformly accelerated motion. Okay, they are equations of motion that are influenced by what? By gravity. So if I'm told to calculate the horizontal distance covered by a projectile now, I will not use s distance is equals to ut plus r8 square, although s is distance. Okay, I cannot use that parameter, that formula rather, to calculate the distance. Why can't I use those formulas? The reason is that those equations of motion are used to solve problems of motions that are influenced by gravity, by gravitational force. So if I'm told to calculate the horizontal distance of range, now I won't be using those equations of motion. Instead, I'll be using the normal equations of motion that we have. The normal speed is equal to distance over time, okay, or the correct one depending on the parameter I am given. See, let's make this very, very practical. Let's look at this particular question. A boy standing on a vertical cliff 80 meter high projects a stone horizontally. I take it again. A boy standing on a vertical cliff 80 meter high projects a stone horizontally with a speed of 30 meters per second. Determine the time taken to reach the ground and its range. According to this particular question, this guy in question is standing on a vertical cliff, and when he was standing on the vertical cliff, he projected the stone horizontally. That word horizontally is the most important word you need to solve that question. It tells you the direction of the stone. The guy did what? He projected the stone in the horizontal direction. That very point of projection, the vertical component of the stone is 0. The what? The vertical component of that particular stone is 0. The stone was not moving in any direction vertically. The stone would have had a vertical component if the boy had projected it downwards, okay, or if the boy had projected it at a particular angle. If the boy had projected it at an angle, okay, then the stone would have vertical and what? Horizontal components. But because this boy only projected it horizontally, at that point of projection, the initial velocity of the stone downwards is what? 0. However, the horizontal velocity of the stone is what we are given in the question, which is what? 30 meters per second. It is only after this stone has moved some distance forward before gravity begins to pull it down, okay, it begins to acquire some distance, begins to move some distance in some time, begins to have some speed downwards. But at that very point where the stone was projected, the initial velocity is what? Is 0. So the question asked us to calculate the time taken for this stone to reach the ground level of the cliff. Okay, I can use the equations of motion, the right one, because gravity is actually what made the body to come down. Without gravity, the stone would have kept on moving horizontally. So I can use h is equal to ut plus half at squared. Okay, then u is the initial velocity there. The initial velocity downward was 0. Automatically ut becomes what? 0. What am I left with? H is equal to half 80 squared. The h there is the distance, the height of the cliff, which is 80 meters. By the time you do the calculation, as you can see on the screen now, you should end up with time equals 4 seconds. So it took the stone or the projectile a distance, a time of 4 seconds to do what? To get to the ground level. The second part of the question is for us to calculate the range. The range is the horizontal distance covered by that particular projectile in question. You see, this particular horizontal distance covered is not influenced by gravity. Gravity does not act in the horizontal direction. So there is no way gravity is going to influence the what? The horizontal motion of the stone. Okay, so for us to determine the distance, the horizontal distance now, I can use the normal equations, which is distance is equal to speed times time. Of course, the speed horizontally was that 30 meters per second with which it was projected at the initial point in time. Okay, so if you keep on moving with this speed, neglecting air resistance, initially you projected it with what? 30 meters per second. It keep moving with that 30 meters per second till time infinity, neglecting air resistance, or till it lands on the floor. So the point here is that the horizontal component of that particular motion, the velocity for the horizontal motion is what? 30 meters per second. So distance is equal to speed times time. The speed here is the what? 30 meters per second time. The time it took it to land on the ground, as we have just determined, is what? 4 seconds. 30 times 4, 120. So the horizontal distance covered is what? 120 meters. I hope you get the point now. Am I communicating? Fine. In order for you to solve some questions on projectile motion, there are some particular concepts and some particular terms and some particular equations that you also need to know. For instance, you need to understand what is called the time taken to reach its maximum height. The time taken for a projectile to reach its maximum height is given by the formula u sin theta over g. U is the initial velocity, theta there is the angle of projection to the horizontal. Please, if the question gives you the angle of projection to the vertical, convert it to the one to the horizontal. How do you do it? 90 minus theta. The angle to the vertical, you just subtract that particular angle to the vertical you were given from 90 degrees. Don't worry, we're going to solve a question very soon, and you get the point, okay? Now, we also have the time of flight. The time of flight is the total time taken for the projectile to move from where it was projected upwards and back to that same plane. Like, in short, the time of flight is the total time the projectile spent in air. The formula is what? 2u sine theta over g. Fine. The next one you need to understand here is the maximum height. The formula for the maximum height is what? U square sine square theta over 2g. You need to understand that. Sine square theta means sine theta times sine theta. You can see it on the screen now, okay? Sine theta times sine theta. If I give you sine 30 now, sine square 30 means sine 30 times sine 30. 0.25. Yeah, that's what we mean by what? Sine square theta. Then we also have the range. Yeah, the range is given by u square sine 2 theta over g. Yeah, u square sine 2 theta over. Only the maximum height contains over 2g. If you are confused, only what? The maximum height contains what? Over 2g. All the other formula is over g over g over g. Okay, let's solve some questions here to better illustrate this concept. A projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 60 degrees to the vertical. You see, they say vertical here. Okay, so the theta you are going to be using will be what? 90 minus 60. You are giving 60 to the vertical. To get the theta to the horizontal here now, your theta is going to be what? 90 minus 60, which is equal to 30 degrees. That 30 degrees is the one to the horizontal. Okay, calculate the time taken to reach the maximum height. Time taken to reach the maximum height, not time of flight. So time taken to reach the maximum height, and also determine the maximum height. It's very easy. Let's write out the parameters. Number one, we have our theta, the angle of projection, to be equal to what? 30 degrees. Okay, fine. And what is the formula for the time taken to reach the maximum height? I just gave you now. T is equal to what? U sine theta over g. You agree with me? So by the time you do the calculation, 300 blah 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 blah, as can blah it on the screen, then you should arrive at 15 seconds. Yeah, 15 seconds. That is for the first part. The second part says I'll ask you to calculate the height, the maximum height reached. What is the formula? U square sine square theta over 2g. It is the maximum height that has what? 2g. By the time you do the calculation, as can blah 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 it on the screen, you should arrive at 11,250 meters. Yeah, 250 meters. So I'm very sure that you enjoyed watching this video. You see, time would not permit me to keep on making examples. A good way to gain a very good mastery of physics is by solving questions. In view of this, I'm going to attach some questions in the comment section of this video. After watching this video and understanding the concept, make sure that you attempt those questions. There are likely questions in your UTME. And after attempting them, submit them through the link that you are going to see there to get the answers automatically. So do not forget to subscribe, like this video, and there are many millions of JAMB candidates out there. You need to share this video to them so that they would also get to know about this particular topic and understand it very well, and also get to learn more about the subsequent videos. So thank you very much for watching. Make sure you like this video, subscribe to this channel, and share the video. Thanks.